Yeah, so greetings. So this is an assignment that I gave to one of my beginning CAD classes at CMU. It's a piston. So this is what the drawing looks like. And for the benefit of my students, I'm going to show them a solution to how to model this inside of CATIA. So let's begin. So in CATIA, I've already got the first sketch started. Again, this is just one solution. There are many solutions that would be adequate and meet my expectations. But I do have one sketch already started. Notice what it looks like. Now, the reason why I'm doing it this way is because I'm incorporating the the essentially the inside part of the piston within the first sketch. I'm going to do a revolved feature. There are several dimensional constraint expectations I'm expecting from my students. One is this depth here, which is this 12 millimeters. I'm expecting that to be somewhere in the part model. And then also notice that I put my default working working planes in my axis system, or not my axis system, but my origin for the sketch here. And that's 35 millimeters up from the bottom. And this is where the hole for the piston that connects to the connecting rod and the pin that would go through this hole. So essentially the center of my working world is going to be right here and here in the center of the part. So that's just my modeling strategy for this, because I'm thinking ahead about how this piston is going to go into an assembly model later. And so I find it might be easier if I put these default reference planes right here. So again, a modeling strategy. So I'm going to get out of this. Let's revolve this as a shaft. So I need to make my part body the current working location. So right click, define a work object, and then I'm going to do a shaft of this. And there is an axis in this sketch. Excuse me, so it should revolve fine. So there's where I'm setting it right now. So the next feature I will do will be the piston rings. So if I'm looking here, I've got right now 4 piston rings. I've got a little detailed drawing of that. Each ring is 3 millimeters square, and it's 3 down. So I'm going to use the Project 3D Canonical Silhouette Edge tool to help capture that. So I'm going to start a new sketch. So I'm in my sketching environment, and then I'm going to change to construction, and I'm going to go under operations toolbar, and under project 3D elements I'm going to select project 3D canonical silhouette edges, and that's going to project the limiting elements onto my sketch plane as construction geometry, since I have construction geometry selected. So disregard that warning, but you can see those limiting elements projected here onto my sketch plane as construction geometry. So turn back on standard geometry, and the rest of this will be a square and dimension it. Oops. There you go. Mouse is not working today. Blame it on the mouse. So make these their proper size, 3 millimeters square. I'm going with 3 and 3. I could do a 3 and equal length, but either way is fine. Now, the reason why I tie it this way is because if I make a diameter change for my piston, I want the neck to go with it. And there's several ways to do this, to include doing a formula, but I prefer this Project 3D Canonical Silhouette Edge. So I'll get out. Now I can do a revolve of this, and I did not put a sketch in that, so let me go back in. Now I'll just do it around the z-axis. So let's do a groove, and for the axis of revolution, if I'm looking at my compass, I've got z going vertical, so I can go z-axis, and there's my first neck. Now I've got 3 more of these, so this is a pattern, so I can select that, and notice I forgot to put my sketch inside my wireframe, but that's okay for now. Define a work object, and I'm going to do a pattern of this. Mine is one for me over here for not putting my sketch in a geometric set. Instead of current solid, I just want this groove, and I would like to go in the Z direction. So right click in my reference direction and go Z axis, and I'm going to do 4 instances, and they're spaced 3 apart. Preview it. I'm sorry, they're not spaced 3 apart. They are spaced 6 apart. Let's see what that does. And I'm still going the wrong direction there. So let's reverse that. Let me look at what we got. And that is not correct. Let me try that again. Oh, there we go. Yeah, that works for me. Okay, so the total length of this, so if I'm looking at my drawing, I need to back up here a step. If I'm looking at my drawing, the total length of my pattern is 24. So if I want to capture that design intent, I really need to change this to be instances and length. So I've got 4 instances, so I need to change this length to 24. And that's going to be more correct according to my drawing. So I got my pattern in. Now let's focus on the inside of the model. So if we go back here, you notice we've got a little boss in the middle here that's been pocketed out, and this allows for support for the pin that will go through the piston that connects the connecting rod. So what I'm going to do is I'm going to create this with a circle in the middle, and then I'll do a 2-directional extrusion up to next or up to surface to create the inside, and then I'll pocket it out. So let's begin that. So start a sketch there. And again, another advantage of having my default reference planes right here where they're located. Let's do a circle. And that size is 26 in diameter. So 26. Get out. And you see my sketch. So from here, I can do a pad, and let's try a pad. Several different ways to do this, but let's start with a pad. So I can do an up to next. Notice it blends in with that feature. Let's see if an up to surface will work. Yeah, that worked fine. Now let's try the other direction. So I'm going to do an up to surface in the other direction, and so that blends in with that surface really well. Okay, and that's the start of the inside. So I have a gap here, of course, and this is essentially the nominal size of one of the ends of the connecting rod. So it's 20 millimeters across, so 10 on one side, 10 on the other. So let's begin that one. So I'm just going to do that as a pocket, and I will remember to put this inside of my geometric set this time. So I will start my sketch, and just flip it to the other side. Go. And I'm going to use symmetry constraints on this. So pre-select across there and do symmetry, and then pre-select across here and do symmetry. I could do project 3D canonical silhouette edge to tie in here tightly. I think I'll just over exaggerate it a little bit. Probably not the best modeling scheme. This though, it does need to be 20. And I'll tell you what, I will do project 3D canonical silhouette edges. So make sure it's construction. That is a silhouette edge. So notice how that came in as a silhouette edge, silhouette edge. let's tie these two together. So I'm going to do a coincident between there and there. There we go. And that should work. And what I'm just trying to capture the design intent. And so if this pin and this size were to update, then this will update with it. And I won't run into any problems later down the line. So get out of the sketch, go back to my part body. Let's do a pocket. And we can go through all that direction, I think. Let's try that. Up to last. And then the other direction. Let's go up to next. And there we go. And there's my pocket. Now we're sitting here with, we're needing holes on both sides. So I always teach my students to use a hole when you have a hole. But in this scenario, I think I'm just going to do this as a pocket. So let's go back into my wireframe geometric set. I'm going to come out and sketch right there, just for the benefit of my students. You can do a section, cut part by sketch plane, just to see where I'm sketching. And let's do my whole sketch. And that's showing a diameter of 20 millimeters. So I'll make that 20 millimeters. Get out. And so there's my sketch. Now I can take that sketch and do a pocket. And so I'll do up to last, go in both directions. And there's my hole going through. So a basic shape of my piston. Now I'm lacking a chamfer at the bottom, which is a 2x2 chamfer. I'm also lacking my fillets on the inside. So let's put those in last. So let's go with the chamfer next. So select the chamfer tool. I'm going to do length and length. Yeah, length and length is fine. So we'll do 2 and 2. Select that edge. There's my chamfer. And then fillets for the unfinished surfaces on the inside, which will be this bottom corner and around this edge of the boss. So let's do, and radius is 2. So I've got a fillet. Make sure I do edge select. So I don't want to do a face select. So I'm just going to hover here briefly. And when I see edge, I'm going to select. And it should be a 2. And then hover, edge, select. Hover just to make sure I'm selecting an edge. Preview it. And that's my fillet on the inside. And that's my model, my complete model. So that's my way of doing it. I've seen students do it other ways, and I thought was adequate. And I've done it other ways as well. A couple of things as I work through this. One is I forgot to put this sketch down here. Now, one way to work around that is to copy paste, because this is a body, right? So I can't just move it to a geometric set. But I can copy paste this one in and then redefine the sketch as that new copy. Sometimes that works, sometimes it doesn't. I'm not going to worry about it here. And then I wasn't really thinking through at first the pattern parameters. As I was looking at my drawing, I started thinking, okay, so I've got a 3x3 groove, 3 from the top, and then I started thinking, well, it's got to be 3 spacing. And then I did that, and then I started thinking, well, that's not right. And then I went and looked at the drawing. I noticed it was 24. I've got my 24 parameters. So that's telling me what we're needing here will be at 4 instances, 1, 2, 3, 4, over a total length. And notice how this length is going from that point to that point. So that's a total length of 24. So then it clicked on me that instead of doing spacing and instances, I should do instances and length. So notice here I've got a 4 as my instances with a total length of 24. So there you go. So I hope that helps. Have a great day.